welcome to the Apollo demo. We're trying to show how Apollo's working from a high-level architecture, and we're trying to show the simplest use case for a quick start you can possibly have. So our idea is to spin up a virtual machine at HETZNER Cloud, because HETZNER Cloud is pretty cheap and still has pretty viable technology. And that virtual machine will be provisioned with Apollo, so we can have a working container platform as an end result. So first thing, we're gonna start a new project. Whoa. At HETZNER. Let's call it 2 because we have one again already. So in that project we first need actually an API token for read and write, which we can copy. And then we go to a terminal, and I'm starting off at home Apollo spaces because that's my space directory, but actually it doesn't matter. Once you start Apollo init, and I assume you got through the getting started guide and already set up your alias, because this is merely an alias for the docker run command. So I'm initializing a space now. I want to create a new one. And it takes a while. I just updated Docker on Mac and it got a lot slower. So what we need is a name for the environment. That's how the space is being saved, and it's actually also used for the space domain. The base domain will be paas.p3r.engineering in our case, because that's the domains I'm using to run my Apollo spaces. We need an email address for Let's Encrypt, and we want to enable infrastructure, which in this case means we want Apollo to deploy infrastructure for us. We want hcloud, and we have that API token. So Apollo now generated a space file for us. First things first, we need to cd to the directory that has been created. Look at that. And there we find a space file and an SSH folder. The SSH folder, as expected, contains SSH keys. They have been generated during the init process, and they will be used to connect to the machine. So they have been provisioned to DigitalOcean or HETZNER or whatever. In this case, it happened automatically. If you provide your own nodes, you will need to make sure that this SSH key will be added to these nodes so you can connect. Let's look at the space file. It's pretty boring. It has been generated from the defaults, and most of it is pretty not interesting. We're starting off with an admin user called Apollo and a password called Apollo. And the only things we changed is here the auth token, and inside the infrastructure part, we defined hcloud as our cloud provider of choice, and Ubuntu 18.04 as the image we want to start. We want to start with 1 manager node and 0 worker nodes. We don't want any volumes. That's not interesting for us now. If you run Apollo in a distributed setup, so multiple machines, and you want a distributed hyperconverged storage, you can look at storage.com. We included that, and that's what you need these volumes for. It's at least 3 volumes per node, so you can have that storage cluster running. So that's it. Basically, from that point on, we can run Apollo build, which will build our infrastructure, and spin up the virtual machine at HETZNER. Again, it'll take a little while. We are using Ansible to invoke the templating. Templating means, in this case, we're generating Terraform templates, or we're having Terraform templates, and we're generating actual Terraform files from it. And these Terraform files, as you can see, produce viable HETZNER Cloud infrastructure. And these Terraform files can be found in your space directory. We will have a look at them now. You see there's main.tf, output.tf, and of course Terraform plan and Terraform TF state. So for main.tf, it's pretty boring. It simply specifies hcloud server and worker versions with a specific count. We have 1 manager and 0 workers. Blah, 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 foo. So basically, we're templating with Ginger. We're templating these Terraform files. and putting them to your space directory, which means they are an artifact now. Um, Once you change the number of nodes in the space file, these templates will be changed up too, and we will run another Terraform plan, another Terraform apply on top of it. So infrastructure changes. That gives you the opportunity to, one, use our included infrastructure deployment, where we currently are supporting hCloud and DigitalOcean, or two, you can simply provide your own Terraform files and do as you like. The interesting part is you need to specify either this output.tf file, which basically saves a file called nodesfile.yaml in a specific format into the space directory, so in the same directory the Terraform files are in. This nodes file will be used by Ansible, specifically by the Apollo inventory Python script. Will be parsed for the nodes and the management and ingress IPs, and a beautiful inventory will be compiled from it that Ansible can use to connect. So basically you can either take the automated approach where you add Terraform output code that saves the node file to your Terraform files. That means if you're using a different provider than hCloud, you have to replace these resources, but it's actually pretty easy because we're only looping through the server items and taking their IP address for management and ingress. Or you can simply provide your own nodes file. You see the format is pretty easy. You can simply write it by hand if you want. So next step, now we got all the files and infrastructures to run Apollo deploy, which in this case deploys Apollo to this machine. If you have a multi-node setup, it will of course deploy Apollo to multiple machines. The whole idea is to have a declarative infrastructure and platform configuration, so space file and nodes file pretty much sum up what the expected infrastructure and platform will look like. And with the means of Ansible, we're introducing these machines, or we're instructing these machines to form the platform we've just described. The aspect of immutability is basically what drives this. We want to have an end-to-end configuration for a container platform, including add-ons and applications and services the platform has for the developers. That enables you to basically work with your infrastructure and platform in a GitOps style, GitOps workflow. Checking it into a Git or GitLab, in our case, repository, applying CI/CD mechanisms to it, and have all the process we're currently going through here manually being done by a robot. So the end result will be working infrastructure with certain properties and attributes, and Apollo is already prepared to audit this infrastructure. So once everything's deployed and provisioned, and once all the bells and whistles have been run, we can basically implement an RSpec based system to test and to audit all these systems to make sure everything is as expected. And we can automate that in CI/CD. So Apollo is basically designed to be deployed and maintained headless. And we're using Ansible to make sure we can compute a certain kind of state without saving too much of the state. So what we're now doing, we're trying to, we're sitting to the space directory again, where we can have a look at what happened since we started the deployment. So for one, we have new files. We have a gitignore. We have .terraform, where Terraform initialized all its modules into, while gitignore should typically hold information to not track this directory in Git. Then we have a logo PNG, which is basically a Quark representation of the link to Portainer to manage your platform. That's just a neat feature. If you check this into GitLab, or maybe even GitHub, the logo.png will be automatically set as a repository logo, which gives you the ability to list all your repos with QR code logos and scan them, and bam. Yeah, just a fun thing. I like stuff like that. So, important is the README. It's basically markdown information that has been automatically compiled from your space file, nodes file, and the Apollo configuration system, where you can see what's the active container engine with links to documentation, and you can see what's your manager nodes, what will be your worker nodes if you had one, if the backups are enabled, what's user and password for authentication, base domain, incrus IP, management IP. There's a difference between the incrus and the management IP, even if it's both the same here. Let's say you have a multi-node setup consisting of one manager and 3 workers. You would assume in Apollo the manager is doing management stuff, so it's running the metrics and logging stacks, and it's basically a huge attack vector. So we point the management IP to the master or the manager, where we're running the metrics and Prometheus and Grafana frontends. And then we're pointing the incrus IP to any or all of the worker nodes, because we actually expect the user to run their workloads only on the workers. Since we're running Swarm or Kubernetes, it's basically not an issue to have the incrus IP and the management IP be the same, because let's say we're in Swarm and our incrus proxy, which is traffic, opens port 80 and 443 on basically all nodes of the cluster. But we explicitly want to traffic to not hit the manager node, because let's say you're running a high load, highly scaled application on top of Apollo. Traffic hitting the master node directly might take it down, might open it as an attack vector for potential hackers and stuff like that, people that want bad stuff. So we're trying to hide, but it's not actually hiding. We're trying to hide the manager node from public viewing, and pointing the incrus IP to the worker nodes means you can, one, have multiple incrus IPs, which means you can overload the DNS records, multiple A records, and actually use the incrus IP to point DNS records to the cluster. As you see here, you should set an record to the space domain and a wildcard record on top of it. But you can also have a totally different host name hitting the cluster. But make sure your application workloads, let's say you're deploying GitLab on top of it, is bound to the incrus IP, while the management stuff stays at the management IP, which is the IP of the first manager. Sorry. So in terms of the README, it basically outlines a few things around the cluster. Tells you how to SSH to the machine. Tells you how to also SSH to the machine depending on from where you're coming. Gives you a little bit of information about VS Code remote development, which is a cool feature. So you can basically use VS Code to connect over SSH to Apollo Space and then get going really, really fast with a local Docker socket. Basically use Apollo as a remote development machine. And then we have these links here which point us to later available analytics systems, the proxy alerting systems, and here we have Portainer and the incrus proxy. So this README is auto-generated every time we're running Apollo deploy. Okay, that warning is new, interesting. Yeah, cool. So this README is automatically generated whenever you deploy Apollo. It's just to make sure that you as a user have a point to go to see, depending on your running configuration, your space file, nodes file, and whatever else you configured, what is my system currently composed of. And the idea behind that is to get the need to document stuff out of your way, because if you operate multiple of these systems, you will forget to document stuff. And so at that point, Apollo has already started deploying the metrics system. So we're having a management proxy up in terms of traffic. Traffic is being used for the management and the incrus proxy, but in different versions. After traffic, we're deploying the node exporters, the process exporters, and all kinds of metrics collection systems to the nodes, even CAdvisor and Docker Swarm setup. And after that is done, we're deploying the actual metrics collection systems. So now we've reached a point where Apollo is readily deployed and we can actually start looking at what we got. Yeah, this is expected. We've not set up DNS. This is something I've got on my to-do list. We could basically hook up DigitalOcean or Cloudflare or whatever with Apollo and ease that step a little. But oftentimes I feel it's not worth the effort. But yeah, then again, I need to do this manually and then wait for stuff to work, which is also pretty disappointing. Let's see if it works now. Nope, nope, nope. Grafana dot Apollo demo 2.bas.p3. You see, DNS is basically a very cool thing, but it's also the pain in the ass because it's so old and so slow. So we want to open that website, we want to visit that website, and we should be presented with still more stupid verification issues. Then we can log in as Apollo and password is also Apollo, which presents us with one more login screen for stupid Grafana, and then we can save our password and get going. You see, we come with a few pre-provisioned dashboards. You can't use all of them. Let's say the S3 one and the storage one. Or NFS one typically only works if you've got these services also enabled, but what's working is the nodes dashboard, where you can see, yeah, few interesting informations of cluster uptime. So we're up for 13 minutes since the last reboot. We have a total of 8.2 gigabyte RAM, still 89% available. System load is okay. Yeah, you see, you get valuable information out of the box for your nodes. Of course, if there are multiple nodes, that's summarized. Then we got the orchestrator information, which is my personal favorite. Once you start deploying applications to it, they will their containers and services will look up here, start up here. You can see we currently have 2 stacks, 3 services, and 3 containers. We're running the Portainer agent, Portainer itself, and the proxy. You can see the cumulative CPU usage and by container, and the same for memory, which is very interesting. Once you start deploying stuff to the cluster, you can pretty much learn everything about its performance. Yeah, in terms of dashboards, one of the more interesting ones might be the processes dashboard, where you can also see all the processes currently running on the cluster. And at a certain point in time, the traffic dashboard, where you can monitor your ingress and egress stuff. Okay, so next cool feature, you can crawl through these metrics like like you would expect. We can hook up Jaeger instances too. Yeah, simply work through the metrics and query them like you used to from Prometheus. But we also got logs here, so you could say, give me all the logs from systemd. Okay, here you go. And then you can crawl through your logs from systemd. And if it's not systemd you want, maybe you want, I don't know, containerd service. Here you go, logs for containerd service. So Apollo features a centralized logging engine that pulls logs from systemd and var log on every physical node, so on every worker or manager on the cluster, and sends it to Loki. Loki runs on the manager node. Loki ingests them and tags them and does stuff with them, and Grafana makes them accessible in this explore section, so you can not only watch your logs, you can still, like in good old Grafana, add annotations and advanced filters, putting alerts on it. Grafana is doing very much work on their end to improve the logging experience and doing the development of Apollo the past year. They released so many huge and nice upgrades in terms of stability and speed and stuff like that. Yeah, we're very pleased to have this on board. And once you start deploying services to Swarm or Kubernetes in the end, you will have these special stuff here like Swarm Stack, where we can see what our proxy stack is logging and that it's trying to obtaining a bundled sound certificate and stuff like that. So you can basically get a hold of all the jobs and all the logs of the cluster you want to have. So much for that. We could try to get a look into Portainer. I'm not sure if DNS has already caught up. Yeah, looks good. Let's see. I'm not sure why this is an insecure connection. But maybe we're getting a 404. No, we don't. Okay, cool. It says it's insecure, but it should be secure. But here you go and see Portainer, which should show, yeah, exactly this. One failed service of a Portainer agent and 3 other ones. And if you're familiar with Portainer, you got the full feature of Portainer. You can run and delete and watch and look and manipulate your stacks and services. So you can either watch the logs or you can go into the command line and dive right into it. Oh, maybe that was the wrong thing. I don't know. Maybe it's not ASH but bash. Not sure about that, or not sure if Portainer actually features that. But yeah, you can use this Portainer instance and hook up more Portainers through the Edge client. You can hook this instance up with other services. And yeah, in the end, you can work with everything Portainer has to offer. Not sure what to say. That's basically Apollo. So you got this container management interface to manage your containers, and you got Grafana to look deep into your cluster and into your application stacks. And besides that, this repository or these files should typically, ideally be added to Git. We have GitLab CI pipelines prepared that you can simply hook up by including them, that then build and deploy your Apollo instances based on what you've configured here. And yeah, keeps track of your Terraform state and stuff like that. And you can start collaborating. I'm not going deeper into that because that's a topic for another day. But now we've seen how to deploy and build an Apollo instance. And the last thing we should naturally do is clean up after ourselves, because I don't really want this instance anymore. And so I can simply say Apollo destroy. And it will invoke the same Ansible logic as Apollo build. It will issue Terraform destroy and clean up our environment a little bit, because there are a few things that we don't need after that. The Terraform plan files, TF state files, node files, that's actually needed. And as you can see, HETZNER already cleaned up our machine. It probably cleaned up our SSH keys. What it didn't clean up, of course, is the API token. We will do that on our own. So now, nothing's left but the actual configuration of our space. So, of course, we're now able to simply say Apollo build, Apollo deploy again, and then we will have the same thing again, just with a different IP address. And once we work DigitalOcean DNS into Apollo, it's not even necessary anymore to manually set this IP address. So, thanks for watching. Hopefully this gave you some insights. I will prepare a multi-node demo where we're deploying like 3, 5, or 10 nodes. I'm not sure what's appropriate for the next time, if you like. So give me a few words of feedback, and if you want to see Apollo deployed to 5 nodes in a Swarm cluster, let me know.